This problem and all other Calc 152 problems can be found here at Sarai Studies. Link is in the description box below. Anytime you see the word volume and revolving, you want to use time. The first thing you want to do is determine which terms your formula is going to be in. Is it going to be in terms of x? Is it going to be in terms of y? Well, that depends on two things, and I like to remember it as the AM, so, morning. So A stands for axis of rotation, M stands for the method that you're going to use. The axis of rotation is always given to you. It's the y-axis. You want to translate that into an equation, so just take the opposite letter, that's x, so that's x is equal to 0. The big question that everybody asks is, what method are we going to use? Well, the answer is multiple methods can be used to solve the same problem, and they can be just as easy as the other, or sometimes they can be harder. But we always like to start somewhere, right? Just have a rough idea of where we're going. And the way that I like to start is looking at the curves that they give you. If they're in terms of x, meaning the variables are x, which they are, then I would like to keep it that way. Because here's a fact, depending on the method that you use, you will either keep your curves the way they gave them to you, or you would have to solve for the other variables. So we would have to solve for x is equal to y here, and then turn this one to x is equal to something. And that's more work, right? So I like to start with doing the least work. And that means keeping the terms the way they are. So I have to choose a method that will allow me to keep the terms the way they are. And remember, there's only really two methods, because disk and washer are practically the same. If you choose shell, S for same, then the terms of your problem, of your formula, are going to be the same letter that's right here in terms of x. That means that you can keep your equations the way they are because they already are in terms of x. But if you choose disk or washer, D for different, you'll have to take the opposite letter of this, which is y. So then everything would be in terms of y, meaning your functions or your curves will also have to be in terms of y, meaning you would actually have to solve for x so that you can get your variables as y. That's what being in terms of y means, and that's more work. So to me, I'm going to choose the method that's going to give me the least work, and that would be shell. So again, if I choose shell, S for same, so I take the same letter that's here, and that tells me that my formula is going to be in terms of that same letter, which is x. Again, if I were to have chosen disk or washer for different, I would have chosen the different letter, the opposite, which would be y, and that would be more work. So this allows me to keep my equations the way they are in terms of x. So this means that my functions or my curves, y equals, are going to be in terms of x. I'm going to have a dx integral with my shell formula, and the bounds in that integral are going to be x equals to a and x equals to b. Now, this is just a good place to start. It does not mean that it's the best method, because once you get to this step, which stands for method, and you graph your curves, you're going to be able to see if this method gives you a split integral or not. And a split integral is not always bad. Sometimes it is better to do a split integral than rearrange your equations. But sometimes split integrals are kind of ugly, and then we would rather choose another method like disk and washer where we have to rearrange our equations, but at least we don't get a split integral. But then maybe we do get a split integral, and so we would have to choose between which is a better split integral. Once we're done with T, we move on to M, where we're going to skip I. M stands for method, and here we're going to confirm that shell is the method we want to use. In other words, confirm there's no split integral. The way we do this is by graphing. So y is equal to x is always this line. If you forget, you can always make an xy table and plot your points. This we can rearrange to be y is equal to, well, it's this right now, but then we can take out the -1/2 times x, and we can say that this is really a line because there's no square here. So -1x and then plus 0, because y equals mx plus b. The intercept is 0, so that means it's going to be here. It's going to intersect the y-axis at 0. And then the slope is -1/2. So we're going 1 down, but then 2 to the right. So the next point would be here. And then to go the opposite direction, you would just change signs. So 1 up and 2 to the left. So the next point would be here. So you can see that it's this line right over here. Now, they also give you this bound, and that's x is equal to 2. So x equals to 1 is here, x equals to 2 would be here, so the line would be over here. Now you can see that there's a region that's enclosed because of all of the bounds, and this is the region that we're supposed to rotate around the y-axis. But we don't ever need to actually draw the shape or anything, just shading the area is enough, unless your professor says otherwise. But the way we can determine if we have to do a split integral is by remembering that if you're using the shell method, that means you're going to use parallel strips. If you were to have done disk or washer, that would mean perpendicular strips. But parallel or perpendicular to what? To the axis of rotation. So if your axis of rotation is the y-axis and you're using the shell method, the strips that are going to cut up your region are going to be parallel. So it's going to be these. Let's zoom in. If the entire time they're touching the same top curve, so this curve, and the same bottom curve, so this curve, then you do not need to do a split integral. But if at any point in time the top or the bottom switch, then you do need to do a split integral. And we'll do a problem just like that later. But here we don't need to do a split integral. So then that tells me the equations are easy. So that's really good for me because I saved myself some work, because I get to stay in the same terms, and I'm not being punished by having to do a split integral. So shell is perfect, and I'm going to stick with shell. What does that mean? Well, that means that I'm going to need to use the formula. So volume is equal to 2 pi, and then we have the integral from a to b. And shell is just radius times height, but they're functions of x. So r of x and h of x, and then dx. Why is everything in terms of x? Because that's what we figured out in step 1, which was find the terms that your functions or your curves are going to be in. What your d is going to be, it's going to be dx. And then your bounds are also x is equal to a and x is equal to b. Now the easiest thing we can do is figure out what the bounds are, or the intervals. Since everything is in terms of x, that means we're going to be looking at x values. So on the x-axis, where do we start and where do we end? So that's at x is equal to 0. That's where the region starts, and where the region ends is at x is equal to 2. So it's from 0 to 2. That's our interval. Now to find radius and height, I have a little cheat sheet. So both of them depend on what the terms are. So it's either terms of x, terms of y, also here terms of x, terms of y. Now I like to start from the inside out, so think of the movie Inside Out. You're going to have two cases. You're either going to do top minus bottom, so inside out are going to be the same, and then on the outside it's going to be the second case, which is right minus left. And so the things that we're dealing with, if you're on this side, x is going to be one of the things, and the second thing is always going to be this number right here in the equation of your axes of rotation. So that's 0. And then here it's going to be y, and then the same number. Now I'm not saying that x is right and 0 is left, so our radius is going to be x minus 0. I'm saying these are going to be one or the other. To find out which, we have to look at our graph. And I'm going down this path because the terms are x. So if I have terms of x, then I'm going to go down this path, not on this path, because my problem is not in terms of y. So these are really x is equal to x and x is equal to 0, right? Because we're doing everything in terms of x. So x is equal to 0 is right here, right? This is at x is equal to 0. But what is x is equal to x? Well, we're talking about a parallel strip. So you want to draw your parallel strip parallel to what again? Your axes of rotation. So if your axis of rotation is the y-axis, parallel to that would be something like this. Again, it doesn't matter where you draw it. It could be here, it could be here. That's the point. The reason we call it x is because at this point, it's at x, but it could also be here. And so it could be that x. Or the strip could be here, and it would be at this x. So we just say x is equal to whatever x value it is. But the idea is the distance from 0, x is equal to 0 is right here, to this strip, that is what we call the radius. This little strip is the radius. So how can we get that? Well, it's the length of that. What's the length? X minus 0, right? So we see that x is to the right and 0 is to the left. So in this case, our radius is equal to x minus 0, which is just equal to x. So already we have that the volume is equal to 2 pi from the integral of 0 to 2 of x, and then times h of x, which we have to figure out what that is, and then dx. So what is h of x? Well, what terms did we decide? Terms of x, right? So we're going to go down this path. So what do we mean about top minus bottom? Well, again, we're going based off the parallel strip. It's really just what top curve is this parallel strip touching and what bottom curve is it touching? Well, at the top, if we zoom in, it's touching this curve, and at the bottom of the strip, it's touching this curve. So it's this curve minus this curve. So we have that h of x is equal to x, which is this curve, minus this curve, which is negative x over 2. This becomes a positive, and that's it. So you have your h of x is equal to x plus x over 2. And that's your volume. Now you go to E, which is to evaluate. So to evaluate this integral, you want to distribute that x, so it becomes x squared, and then distribute this x, it becomes x squared over 2, plus we drop everything down. This is really 1 times this, so we can take out this 1/2 like this, and then we can use power rule. So plus 1 to the exponent, that's 3, so we divide by 3. Plus 1 here, that's 3, so we divide by 3. Or that's the same thing as multiplying by the reciprocal, which is 1/3. So this is really 1 times that, so we can pull that out, and x to the third, and then plus the second one, which is 3 times 2, that's 6, so 1/6, x to the third, and that's all being evaluated from 0 to 2, multiplied by 2 pi. So fundamental theorem of calculus says, take this, plug this in, and then minus, take this, plug this in. So we have 1/3, 2 cubed plus 1/6, 2 cubed minus 0, 0, everything cancels out, so it's just 0. And then all times 2 pi. This is 8, so 8 divided by 3. This is 8 divided by 6. This can be simplified to 4 divided by 3. And then we can just add, so 8, 9, 10, 11, 12. So 12 over 3, which is just 4. And all times 2 pi, so your answer is 8 pi, and do not forget your units. That is your answer.